अस्सलाम वालेकुम एवरीवन। अब हम शुरू करते हैं। समझ जिस आस्क की उर्दू लैंग्वेज या इंग्लिश लैंग्वेज, so I was just being formal. Let's start now. Again, once, assalamu alaikum and a very warm welcome to everyone joining us tonight. मेरा नाम मोहम्मद मुताहिर है. I'm the program coordinator at ETL Online and your host for this exciting session. So for those who are new over here, मैं आपको पहले बताता चलूं कि what ETL Online basically is. So ETL Online is a non-profit organization with a mission to build a vibrant online tech community in Pakistan. We want our IT students and recent graduates to reach their full potential. And inshallah, we'll make Pakistan's IT industry leaders one day. So to start my session, I invite Mr. Mohamad Ali Khan. Sir, kindly introduce yourself. I just read your introductions, and mashallah, you have quite an extensive background with experience at IBM and as reliability lead, test lead, and at AIB. And then I presume you're currently working at Phineas. So could you
Yeah,
introduce yourself more thoroughly for everyone?
sure, I will do that. Thank you very much. I can start my video so that there is a face to it. Assalamu alaikum. Actually, I'm not sure कोई मेरा जाने वाला इस वक्त होगा या नहीं होगा. मेरा बैकग्राउंड इस्लामिक यूनिवर्सिटी से है और ETL जो है वो somehow is related with some of इस्लामिक यूनिवर्सिटी के जो पुराने दोस्त हैं उनसे. तो 1998 की बात, 1989 की, जब मैं पाकिस्तान में था और आमतौर यूनिवर्सिटी में टीच करता था, इस्लामिक यूनिवर्सिटी में, और एक आध और यूनिवर्सिटी थी, मोहम्मद अली जिन्ना यूनिवर्सिटी और नस्ट, जो उस वक्त स्टार्ट हो रहे थे. तो उसके बाद फिर मैं यूएस चला गया. एवरीबॉडी वाज गोइंग बैक देन. ये 2000 की बात है, 9/11 से पहले की बात है. तो 9/11 से पहले थिंग्स वर वेरी डिफरेंट इन यूएस एंड इन द वर्ल्ड. तो वहाँ मैं ऑलमोस्ट 3 साल रहा. वहाँ पर जो है क्या कहते हैं अपना, कैलिफोर्निया में, बे एरिया में था इनिशली. एट दैट टाइम ये आप .com बबल बर्स्ट था. और एक बड़ी अच्छी स्टोरी है इसमें, जो मैं अभी ये जब मुझे ये कांटेक्ट किया इन्होंने कि आप इस पे प्रेजेंटेशन देंगे तो डिज़ाइन पैटर्न्स पे, तो इसके बैकग्राउंड में एक बहुत अच्छी स्टोरी है. इस वजह से मैंने फुली इमीडिएटली एग्री भी कर लिया, बिकॉज आई वांटेड टू शेयर दैट स्टोरी विद ऑल ऑफ यू गाइस. उसके बाद मैं यूएस से सऊदी अरेबिया गया. वहाँ पे HSBC में कुछ अर्सा काम किया, 3-4 years. उसके बाद फिर मैं वहाँ से यहाँ आयरलैंड शिफ्ट हो गया. तो आयरलैंड में मैं पिछले 18 साल से हूँ. तो पहले IBM में था, AIB में, एक्सेंचर में, और आजकल मैं जो है एज ए कंसल्टेंट फिनियस से कंपनी है उसमें काम कर रहा हूँ. तो लॉन्ग हिस्ट्री है, 20-25 years प्लस की. वो इसमें वो नहीं होगी. लेकिन इस प्रेजेंटेशन के हवाले से, डिज़ाइन पैटर्न्स के हवाले से, एक बहुत अच्छी स्टोरी है जो मैं इसमें शेयर भी करूंगा. और इसको आई डोंट वांट टू कीप इट वेरी फॉर्मल. आज मेरी तबीयत भी कुछ अच्छी नहीं है, बल्कि मैं लास्ट मिनट कैंसलेशन का सोच रहा था, लेकिन फिर मैंने कहा कि ये अच्छी बात नहीं होगी. देयर आर सो मेनी पीपल इन हेयर. तो इट्स गुड टू गो थ्रू दिस. अगर फ्यूचर में हमें ये लोग इंटरेस्टेड हुए तो आई विल गो अहेड विद ए more longer and advanced इसमें डिज़ाइन पैटर्न्स पे वो करेंगे. तो मेरा बैकग्राउंड जो है वो एज एन आर्किटेक्ट है. अब और द टर्म आर्किटेक्ट इज यूज्ड इन सॉफ्टवेयर. आई एम नॉट श्योर, अगर आप लोग मुझे बताएं कि ज़्यादातर लोग जो पार्टिसिपेंट्स में हैं उनका कितना एक्सपीरियंस है. आर दे न्यू, और जस्ट पुट मी, गिव मी ए simple idea that what is the background like, or as is everybody young coming as a graduate, or
Assalamu
uh,
alaikum, sir. Azka
walaikum
this
assalam.
side. Sir,
uh,
thank you so much for joining. Sir, maximum of the students, बल्कि आप कह लें majority जो students हैं वो students ही हैं, bachelors अभी कर रहे हैं. They are still in the
अच्छा,
university. और इसी वजह से I requested to keep it at beginner level. We may have
no,
some young IT professional as well जो graduate कर चुके हों, लेकिन
that's
I
fine.
hope
जस्ट मैंने कहा कहीं ऐसा ना हो कि मैं वो बहुत ही मतलब लॉन्ग स्टोरी में चला जाऊं, तो
नहीं
दैट्स
सर,
फाइन, दैट्स व्हाट आई
थैंक
एक्सपेक्टेड। गुड। तो
राइट सर, थैंक यू।
essentially जो डिजाइन पैटर्न्स का की स्टोरी है, that started back in 1995 or 96, and that was a very important story back then. मैं बल्कि अभी नेक्स्ट स्लाइड पे, और ये मैं बाद में इस पर आऊंगा कि इट्स ए टाइम लेसनेस ऑफ रेलेवेंस। ये जो है उससे डेल से जनरेट हुई भी है। आई विल कम टू दिस स्लाइड आफ्टरवर्ड्स, बट लेट मी गो ऑन टू दिस स्लाइड। 1999 में there was a gang of four. There was a person called Grady Booch. I worked with him in IBM. He was one of the distinguished engineer in IBM, and we worked together in WebSphere application server. तो डिजाइन जावा लैंग्वेज जो थी, दैट केम एज एन ऑब्जेक्ट ओरिएंटेड, प्योर ऑब्जेक्ट ओरिएंटेड जावा लैंग्वेज। अब जो लोग अभी पढ़ रहे हैं जावा प्रोग्रामिंग को, दे वुड इट बिकम्स अ लिटिल बिट हार्डर फॉर यंग स्टूडेंट्स जो नए वो आते हैं कि वो ये अप्रिशिएट कर सकें कि ये जो पूरी करंट लैंग्वेजेस हैं जो अब आप लोग थ्रू ए प्रोसेस पढ़ते हैं, या जो यूनिवर्सिटी और कॉलेज में इस वक्त पढ़ाई जाती है। मेरे अपने दो बच्चे भी अभी ग्रेजुएट किए हैं आईटी से, कंप्यूटर साइंस से। तो वो इट्स हार्ड टू अप्रिशिएट कि ये जो प्रोसेस ऑफ प्रोग्रामिंग है या evolution of programming है, that came over a very long period, and it came through a different milestones that came happen, and design patterns जो है वो एक very important milestone है। Now some of the milestone जो के प्रोग्रामिंग में आए हैं, they were lost. They didn't exist after certain period of time. उसकी मैं आपको एक मिसाल दूंगा कि कुछ चीज़ें ऐसी आई थी जैसे OLE थी, आई एम नॉट श्योर एनी ऑब्जेक्ट लिंकिंग एंड एम्बेडिंग यूज होती थी। दैट वाज ए वेरी इंपॉर्टेंट कॉन्सेप्ट इन आरपीसी। आप लोग शायद पढ़ रहे हो या पढ़े कि रिमोट प्रोसीजर कॉल्स होती थी, कुछ और टेक्नोलॉजीज थी जो, और कुछ और कॉन्सेप्ट्स थे जो कि आए software में, and they vanished. They didn't survive because of the technology, because of the advancement that happened. Design patterns is a very different story. It is the story that goes on. Now it's not told much in here, especially in some of the languages that we are studying right now. For example, जो modern languages हैं, JavaScript or functional programming के languages हैं, they don't stress upon design patterns as such, but they are the actual foundation of all those languages. तो 99 में मैं जब यूएस जा रहा था, तो यूएस जाने से एक हफ्ता पहले मुझे एक हमारे टीचर होते थे, वकास साहब। वकास इज probably still a teacher there. So he arranged that we should have a talk on design patterns. Actually, it was a workshop for a whole day. And that workshop was about the design patterns जो कि Gang of Four ने describe किए थे अपनी book में. That book has just recently come out. Actually, in Pakistan, it came a little late in 99, but it was published probably in 1995 or 6. So उसके basis पे we gave that workshop, and that workshop was about with the help of Java language. Java language was pretty new back then. It was only JDK something like 1.0, and the object-oriented approaches were only being described. So that was considered as a very big niche subject in terms of like how object-oriented approach behaves and works in place of C sharp or no, C++ that was being introduced back then as well. So that was a very good conference, excellent conference. बहुत सारे उसमें participants थे, all were very senior, basically जो पाकिस्तान में जितने भी software houses थे उनके engineers थे, senior engineers थे, and then I left for US. And I worked as more or less as a software engineer, and then after some time in architecture and many different phases of the software development life cycle. 25 years later, somebody calls me. I think Shakil Saab is from ETL, and he called me and he said, "Oh, can you give a talk on design patterns?" I'm not sure whether he knew about this 99 story or not, but he asked me about design patterns, and that clicked me because it was the same time when we were talking in my office. We were talking about design patterns in the context of cloud architecture, and I will come to that later. अगर वो बात हुई तो and I was amazed. I said, oh, okay, people are still thinking about design patterns, and that is very important thing. If you, as a software engineer, if you want to start your career as a software engineer, the main thing that you need to learn is the concepts as opposed to technologies. Technologies go away. Technologies come and go. They don't survive. They will never survive. There is no way that you are coding in JavaScript 1.0 back in, or ECMA script back in 99, and now you into 2024 you will be also coding in that. No, it will not be possible. But the gang of four design patterns, the design patterns by other many distinguished engineers, including Grady Booch, they have written books. They have written many books conceptually and describing all the aspects and design. You can find out a lot of literature on design patterns on the search research, and all these things are foundation for whatever you will do in next 50 years as well, regardless of whatever comes, AI comes or anything comes. So it's very important when you're starting with this your journey to as a software engineer, that you understand the actual concepts, and design patterns is one of the
Sorry to interrupt you, sir. There seems to be a technical
Assalamu
issue. I would like to request you to unmute again, and then we can continue. There seems to be a technical issue. So can you unmute again?
नहीं, there's a lot of नहीं
I
नहीं
think
sir.
you'll have to join again, maybe disconnect and join again. That will probably solve it.
Yes, let's turn it off and on again. The old principle of programming and IT. So I would request you to kindly join again, please. I think the audio is still stuck.
Restart required, I think.
So can you use another mic?
Hello. Hello? Hello?
Yes, sir. Yes, sir. Now I can hear you.
Okay. Let me see if I can share the screen. I'll leave. Okay.
So now you have another story to tell.
My screen is not sharing. No, that's the normal. That's not a problem. It's Zoom is prone to all these issues. लेकिन मेरी जो है screen sharing disable कर हुई है.
All right, sir. I can allow that again.
तो कहाँ
Can you
तक
share
आपने
your screen now?
Okay. Excuse me. You see my screen now?
Yes, sir. Yes, sir.
See. Okay. तो कहाँ तक हम थे? I was going on this slide about the design patterns.
Yes, sir.
Okay. So what is the design pattern? Well, basically, a lot of the terminology and a lot of the concepts that came in software engineering in the very beginning were from civil engineering. And civil architect was at that time was considered as a foundation of many of those concepts that were for building the structures. Now, in civil architect, the structures were basically blueprints that you will design for us as an architect, and then those designs will be implemented by actual masons or actual people होते थे जो उनको implement करते थे. Now, the same concept was applied in software engineering, although that concept didn't work too long. बहुत सारे जो बाद में डेवलपमेंट्स हुई सॉफ्टवेयर इंजीनियरिंग में उसमें सिविल इंजीनियरिंग के कॉन्सेप्ट्स को पीछे कर दिया गया था. But design patterns survived that. Design patterns are still considered as one of the key concepts in terms of architecture. So what happens is that and I will come to that slide where we talk about design versus architecture, design patterns versus architecture patterns. So design pattern simply abstraction है इस चीज की कि आप किसी if you are a civil engineer, if you try to be a civil engineer and you start to think about कि आपने एक कमरा बनाना है, तो you are not creating all the 4 walls first and then deciding how those walls are connected with each other, what kind of material you are using, what kind of different styles you are using. You basically design a blueprint कि wall size क्या होगा, wall को अगर वो एक किचन की wall है तो उसमें किस किस्म का material होगा, अगर वो एक बाहर की wall है, boundary wall है तो वो क्या किस type की होगी. And all these things that you think about it in terms of abstraction as opposed to actual concrete implementation of a wall. And same exactly happens in design patterns. When you are thinking in terms of object-oriented approach, and design patterns not only apply to other places as well, but they are actually started with the object-oriented approach, because in most of the the original functional languages, the design patterns were not as such a term that they use to describe abstraction. But in object-oriented, they use the design pattern as the abstraction concept. So what you do is, you think about it like this, that you think classes as your abstracted artifacts and objects as their implementation. And a design patterns is something which will comprise of those things, identify कि unko आपस में कैसे लिंक होना चाहिए फॉर ए पर्टिकुलर सोल्यूशन, और वो उस स्ट्रक्चर को इस तरीके से डिफाइन करे कि वो आपको एक सोल्यूशन प्रोवाइड करे, एक I'm not sure if I'm speaking good Urdu, but it will provide you an abstraction towards a solution for a problem that you're thinking of. So that's how a design pattern is defined. Now, the design pattern itself is not a solution to anything. It doesn't have any implementation as such. It can be applied to different implementations. It can be used to implement certain things, not as such it is a solution in itself. So there are 4 things that you need to consider when you are talking about design pattern. Number 1, dependencies. Number 2, structures, their interactions, and the conventions. Now, this final one, which is basically the convention, that plays a very vital role. I will come to that. That will be a little bit more one. Now, architecture and design patterns, these are 2 interconnected concepts. And I'm not sure if you remember, you're still taught in college as Corba. Corba was one of the object-oriented distributed architecture that was used, and that was very complex architecture. But usually an architecture for a application is a very high-level framework. It basically provides a complete solution. It gives you a lot of abstractions at different levels, not just at one level, and it defines how the system is connected with different components internally and externally. Whereas the design pattern is a rather lower level architecture. It's more like where you are actually defining reusable components. ऐसी चीजें आप define कर रहे हैं जिनमें आप एक कॉन्सेप्ट को डिफाइन करते हैं, और उस कॉन्सेप्ट को डिफाइन करने के बाद अपने आर्किटेक्चर में उसको इन्वॉल्व करते हैं, और इन्वॉल्व करके you do some implementation. So an architecture is a higher level framework and design pattern is a lower level framework. Now, I'll give you an example. Let me see if I can. Okay, let's talk about reuse first before we go on an example. Stop me if you have any questions. Everybody, you feel free to put a question in the chat window, and maybe I can keep an eye there, and I will take them at the end once I'm finished with that. I have chat window on this side. So now there is a big concept in any aspect of software engineering, in every aspect of software engineering. It's called the reuse. Reuse is about everything. And now, since we have the infrastructure as a code, previously we used to have systems that we will build, but now we have code that build the systems. So that is called infrastructure as a code. Similarly, there are concepts in terms of the actual lower level components that can be reused, and so on. So the reuse is the most important concept in software engineering, or probably in any engineering discipline. So even if you are in electric engineering, electronic engineering, you have to reuse. And the more you can reuse different aspects or different things, the better it is. So in this context, there is a distinction between code reuse and the design reuse. And design reuse applies to the design pattern. Code reuse applies to the programming languages, artifacts, for example, libraries and other stuff that you build. So the important aspect is that the first thing, you don't want to reinvent a wheel, and that you will always find. As a young engineer now, you got ChatGPT and other generative AI things. Now you have an assistant, you have a collaborator that will always help you to identify something that has already been done. I used to share a very graphic, which I didn't find. It's been long. I don't remember when I gave last shared it. But it used to be that whenever you are reinventing a wheel, always remember that your first wheel will be a triangle. It won't be a square. It won't be a circular wheel. So never try to reinvent the wheel, because the wheel that you invent as yourself will always be something that is not a wheel. It will be a triangle or a square or something, and then you improve on it, and then it basically it becomes a wheel. So it's better to always take a wheel that has already been invented and reuse that. Similarly, when you are doing the code reuse, you need to find the good code, stable code, more understandable, clean code, as clean code practices are there. And you also make sure that you leverage your previous work, your own previous work, or your company's previous work, or your colleagues' previous work, or even open source work. In terms of the design reuse, what happens is that instead all these three things remain same except the middle one. What you want to reuse is the common understanding of a recurring problem, right? So there, whenever you are designing a software, you will find that the same thing is always same challenges come to everyone, even if you are building IoT software or you're building a banking software. You will always get, sorry, right. Sorry, I got my key. Thanks. So you will always find that there is a common problem, and usually there will be a common solution for that. And that's what the wheel is about. So you want to find first of all, a common understanding of a given problem. If you don't have a common understanding of that problem, you won't find a reusable solution. So the design patterns are all about reusing the solutions, reusing something that has already been done, and you basically want to reuse that in your own problem or in your solution. Just okay. Any questions so far? Anybody wants to stop me for a moment? Okay. So this is a very nice. This is the oldest, probably 1999, that we used to talk about, and these are the 17, or I guess something like that, design patterns that were documented by Grady Booch and his people, those 4 persons, and they are still being taught. They are still being used. As a matter of fact, in IBM was more about architecture a lot, and that was when I worked in IBM. My department, which was architecture, enterprise architecture department, there will always be a huge emphasis on using the right design patterns. Now, as I said, a lot of the time, these design patterns are already embedded within the solution. So most of the young generations will be using them, but may not be knowing them. But it's very important that if you, as a matter of fact, if you are starting your coding or your learning for any language or any programming language, wherever you find these words like adapter, bridge, factory, singleton, just remember that these are the design patterns, and whoever has written that code actually has implemented this design pattern in his work. And you'll find everywhere, आपको ये proxy, decorator, composite, ये जो है आपको हर जगह मिलेंगे, cloud में, AWS cloud में, Google में, everywhere you will find these terms being used for certain, not terms, actually class names, class methods. Some methods will have these terms being used. And remember, 90% of the time, wherever you find this term being used in a code, they are actually implementing that pattern. And you need to understand why these patterns are being implemented. So I will talk about these 3 different type of design patterns. Excuse me, very just give me a minute. Bear with me, मेरी जो है आज गला बहुत आया हुआ है और सर्दी बहुत है, सर्दियाँ शुरू हो गई। वहाँ पाकिस्तान में सर्दी है या नहीं है? Anybody?
सर काफी ज्यादा है।
यस सर, यहाँ भी बहुत सर्दी है।
सही है, चलो ठीक है, फिर एक ही बात। So there are three different purposes for the design design patterns: a creational purpose, a structural purpose, and a behavioral purpose. A creational purpose is usually when you want to create or produce some objects, and those objects are essentially encapsulate certain behavior, and you want to give those objects in terms of like whether you need a lot of such objects, whether you need a single such object, whether you need an object that can build more objects, and so on. So it's essentially the creational aspect of the object that you are using in your program. So if you are, let's say, developing in Java something, and in order to, let's say, have users, because there will be a lot of users in your system, and each user at any time when he or she is logged into the system will be represented by some something, which will be some object. So essentially what you're doing is you're creating a lot of objects of that kind, which is user object. So when you're creating so many objects, you cannot just keep on creating in a way that becomes uncontrollable, out of memory, and so on. So what you want to do is you want to apply a certain design that is according to the nature of that object, or according to the nature of that problem. So you may have a user factory object that gives a new user every time you ask for it. You may have a Singleton object, which means that you just don't want multiple objects of that kind. You want a single object of that kind, and it is reused by everyone. Of course, that won't apply to the user object, because users are multiple in your system, but there may be some things that are single, that must be single in your system. So you want to apply that. There may be builder object that builds a combination of multiple objects and then creates a final object that it can return, and so on. So this is what we call the creational purpose of our design pattern. And for that, usually we use the factory method, and there are different type of objects for that. Then there is a concept which is like structural purpose. A structural purpose is that you basically are not creating only a single object. You are basically structuring multiple objects into an object that can be used as such. So maybe it is using one or more objects, and then you create a bridge between them. You adopt an object to add more information into that object or behavior into that object. These are all names. They will represent exactly what they are trying to do, and you don't need to worry. And one of the things I will tell you as a starting on the design patterns is that कि आप कभी भी इनके नामों से या इनके जो बुक में बड़े मुश्किल से वो दिए हुए होते हैं, मैं अभी आपको दिखाता हूँ, बल्कि मैंने इसलिए very simple side for use so I use this composite one that was in that book. So now this is a very simplest one, but sometimes in the book you will see कि जो pattern है वो इंतहाई complex, and you will be talking about कि ये UML में कैसे है, and you are worried about how complex it is and how can I understand it. But that is not the real purpose for those design patterns. The real purpose is to understand the concept behind them. And these words that you are reading here, adapter, bridge, composite, decorator, flyweight, they all describe exactly what they are supposed to do. And it's not how they are represented in terms of classes and in terms of those very complex designs, class diagrams. It's more about how do you understand those concepts. And if you understand those concepts, you can actually implement those design yourself. And जो सबसे इम्पोर्टेंट थिंग है वो ये है कि आपने उनको कितना आसान बनाना है. You don't want to make it the complex the more complex a design pattern is, the bigger chance is that it will have a wrong implementation or a difficult implementation. So you need to make your design patterns as simpler as possible, and these patterns become simpler by as you abstract your ideas are different than the actual provided there, right, in the books and in there. Third type of purpose is behavior. Now, behavioral purpose is very simple. It's like this, that you don't want to. So you have created the object, you have structured multiple objects to produce you something which you want to use in your program, and now you have certain behaviors that need to be implemented. Now, I would go through only two of them in here. One is called the strategy behavior, and other is command behavior. So I'll go through them. Those command behavior is very simple and very nice, and it will be used a lot. Even now, as an architect, I will have to use command patterns all the time. Strategy patterns, command patterns, they are the main behavioral patterns that are used all the time in all kind of implementations that you will have. Any questions so far?
Yes, sir, we have one question in the chat.
Sorry? We have
Ms.
question?
Faiza is asking, why should we use design patterns when modern frameworks already solve many common problems? This is a question in the chat.
Okay, great. Let me see, where is the chat window? My chat window, I could not see that. Okay, why should we use the design? Okay, I can see now. Yeah, that's a very good question, and that's what we try to answer in this screen. Yeah. So frameworks are essentially part of architecture. They are defined by the architects in terms of some sort of higher level solution that you need for a given problem. And frameworks are usually at the level where you want to reuse your code in such a way that people can build on top of those frameworks. People can actually build reusing your code. Now, that is a very important aspect. Reusing a code is different from reusing a design. When you're reusing a framework, for example, if you reuse a MVC framework, which is kind of, let's say, in UI, you might have something like React.js. And that is a framework that is designed and has been implemented and is available as an open source library, and you use it. You essentially are reusing the code, and you are building on top of that your own code. Design pattern reuse is very different. Design patterns are not actually the code, and that's what we talked about here in this slide. In the design reuse, you don't actually reuse the code. You may find actually some already written code somewhere for something that you want to use it. That's fine, but you don't actually reuse the code in there. You reuse the design. So a command pattern, for example, a command pattern is a design pattern, and it solves a certain problem. It's a design pattern. You know how to implement that design pattern with the help of new classes, new objects in your code. So you actually are not using a framework, and that's what the code, and that's what the difference is. That the design patterns are lower level lower level than architecture, and frameworks are architecture level. They are the bigger ones. So they are the code reuse. Design patterns are design reuse. I think, and that's a very important question, and that's very important aspect of design patterns. That when you are thinking about design patterns, and especially when you will see in your books those class diagrams that are connected with each other. I want to keep my video on because I give a lot of I use a lot of hand movement. So when you're using this reading about design patterns in the book, you will find out that, oh, there are so many complex class diagrams and making you understand how this particular design pattern, like a complex strategy design pattern, is working. But it's not that you are going to implement exactly those same classes and exactly the same way you are doing your strategy pattern. No, the important thing is that you understand the concept of strategy design pattern, and then you implement that design pattern in your own way, in your own classes, with your own classes. So you're not reusing the classes, actually you are reusing the concepts behind those classes to implement something. Does that give the answer? Yeah, I will continue that. We'll come back to this if we need further clarification on that. Okay, so these are the few of them, and I put them as the one that I've been using, right? In the last 25 years, I've been using them regularly. Now, why I'm using and why it is used everywhere? So they may be used in infrastructure as a code. They may be used in UI-based development. They may be used in backend development. They may be used in all different aspects of development. And I put them in that way that I actually remember using regularly. So you can think of them as the one which, in my experience, were highly used. So if you want to study more about them, I would suggest that you study them, you understand them, and they will be very important patterns that you probably will use in your life a lot. Okay. So I'll go through a few of them. I think personally, I'm sorry about that, but I don't feel a lot better yet. So I will go quickly, and then we will do a Q&A session so that I don't have to speak continuously, if that's okay. So adopter pattern. So adopter pattern is used, and it can be used at different places. It can be used in, for example, code, which you are writing for your, let's say, your website development, web application development, or your some mobile application development. Or it can be used for example, when you are implementing some sort of backend or infrastructure you are implementing, and you need to make sure that you have you basically adopt certain aspects that will be used in a different way. So I give you an example that a lot of the time when you will have database code that is surviving such a long time, like for example, somebody has written a code that was used to basically persist something in the database, and now more like few years later, there is a new version of database, new way of accessing the a cluster or new way of basically storing the data by dividing that into chunks and so on. So there could be several ways, new ways may have come across, but you have an old code which was a very simple legacy code that will take something and store it into the database, and that is still there. It survives. But now you need to take the benefit of the new technology that has come up in your database, let's say Oracle or anything. You may want to write an adapter for your code to be able to reuse the existing code, but fill in the gaps that were there and that were not available previously into the old code. So what you will do is you will have your own client, new client using the latest and API, and then you will be in the background, you will be using the old code to just let's say persist that into chunks or so on. So adapter pattern can be used at every place, wherever you have to adopt to a certain new behavior or adopt to a certain new interface, you will use that pattern and you call that pattern. And that's why one of the things I think I forgot to mention in the very beginning is that design patterns give a common terminology to speak. It's more like that it's not about like what is the code and how that code is written. It's more about how do you speak to each other as a software engineer. So what you would say is, you would say, oh, is this an adopter? Whenever somebody asks you that, is this an adopter? You think of an adopter pattern and you think of something which is adopting to a certain new behavior, certain new structure, certain new API. So that is how you talk to each other. So the design patterns provide the common terminology in order to speak amongst engineers and the architects. Any question on adopter
Can
pattern? I'll keep you very happy.
I have a comment that I would like to make here.
Sure, go ahead.
Assalamu alaikum. Yeah.
Bye.
So the way I understood, and thanks a lot, wonderful session, Ali bhai. But the way I understood the first time, especially this adopter pattern, is जिस तरह हमारे घरों में नहीं होती बिजली के
Adopters.
सॉकेट्स हैं उसके ऊपर आप क्या लगते हैं एडाप्टर लगाते हैं राइट सो द वर्ड
Absolutely.
इटसेल्फ राइट
Is
एंड नाउ इवन टुडे आप एडाप्टर लगाते हैं और उसमें यूएसबी टाइप सी चार्ज कर लेते हैं राइट
very
सो
good
दिस इज
example.
एग्जैक्टली व्हाट इट इज
Exact example. Absolutely right. And I think that is a very good example of not using the civil engineering concept, but the electronic engineering concept. You will find adapters in all the electrical devices. You will find that you are adopting from 24 volt to this volt, or you are adopting from USB-A to USB-C, or you are adopting from A to B. That's exactly what it is. That's adaptive partner. Very well said. Okay, next, sorry. So I put that example from that. But by the way, these slides are shared. I have put the link there for the slides so that you can get more in-depth on that. I found these slides the most interesting one I looked at yesterday. And if you want, on the first screen, there is a link to those, all these slides. So do read about them. And this is exactly what the pattern is like. You have a USB-A and you adopt to the USB-C. So you have an old time and you now adopt to a new time, which is millisecond plus something. Next is the command pattern.
Excuse me,
And again, sorry, go ahead.
Yes, sir. We're running short of time. We have a question in the chat. Mr. Dayan Khan is asking, I hope I'm pronouncing it correct. He's asking, how can junior developers develop an intuition for recognizing opportunities to apply design patterns in their code?
Okay, so that very nice question. So how? Okay, it's not about recognizing the opportunity that we must apply a design pattern. It's about the first question that we talked about in the very beginning. It is that everywhere you have to apply a design pattern. Design patterns are the foundation of everything. Design patterns are, it's not like that, okay, I'm writing this line of code and this line of code is not part of any design pattern and I need to find out a design pattern that I should apply. It's vice versa. It's like this, that whenever you are writing a code, you are supposed to write as a part of some design pattern implementation. So for example, from the very beginning, when you write the Hello World program, which is a single line program, you need to think not as such as a single line of program that printf Hello World. It's basically a design pattern that is outputting something based on some execution or something like that. So you always think in terms of different types of design patterns, and usually design patterns are more applicable in the object-oriented approach, but they are a lot of time now they are being used as part of functional programming as well. But design patterns are like the bread and butter for develop for actually your programs. Every line of code of your program is part of some sort of design pattern, right? So if you're okay, I see another question. For example, how do we use in AI and ML based application? Well, AI is all about design patterns. AI, for example, so there are two concepts of AI that are being worked on very aggressively. One is what we call the machine learning algorithms that we design and train, and then we basically reuse those models in order to implement different types of things. For example, you will train a model, and then based on that model, you will achieve something. You will achieve some artificial intelligence. So a lot of the time, these design patterns that we had read, like implemented 24 years ago, or like Gang of Four thought about them at that time, they are in exactly the same way reusable as a part of the design thinking process in the AI and ML as well. So I give you an example. For example, in the Accenture, when I was working, we had developed an application that will allow the users who are joining the company. And Accenture is a huge company. It's about 400,000 plus employees, 500,000 employees. So the new user will come, and when the new user is onboarding, the new employee is onboarding, you have to give them access to a lot of things, including his user and et cetera, et cetera. So we designed a machine learning algorithm that will allow a person now, and usually that granting of access will require some types of approval from his managers according to whatever the policy is, rules are. So, for example, I can access this system, I cannot access that system, and so on. So when they train the machine learning algorithm to identify that if a person joins this new team, what kind of permissions or he will require, machine learning algorithm was perfectly fine. It was almost 80-90% success rate for identifying what the privileges need to be given to this guy. But the problem was that how do we implement those in the real life applications? How do we make use of that algorithm in real life application? And when you implement them, you actually use those design patterns. And when you are using those design patterns, big question comes in whether your design patterns are solving the problem as it is supposed to be. So when in the very first big phase out of that application, we did that, we identified that millions of requests will be going to the machine learning algorithm, costing millions of euros to the company. And the company was hoping that they will be saving money. They were actually spending more money in terms of those calls to that algorithm, machine ML model, and based on that model, receiving all that data. So then re-architecture of that happened. And I can tell you, we used a lot of those terms, like strategy was big one, facade was big one that we used, and so on. So we had to implement all those new in our architecture, all those existing patterns in order to define a better solution. I'm not sure if that is too complex to get, but I will tell you that design patterns are everywhere. Design patterns will be used everywhere all the time. Okay, no. Any other question?
Sir, I would like to remind about the time constraint that we have. We have very much less time available.
What time is it? Sorry. Do we still have time, or are we done?
Sir, I would request that we move to the Q&A session, and we can study the design patterns later or ask the expert session maybe. Yeah,
that will be better, I think.
So chat, I'm sharing the feedback form. And if you have any
Hello? Can I hear you? Can you hear me?
Yes, sir, I can hear you. And I hope everyone can. Sir,
Okay.
thoda sa, to conclude your session, what would you say? What advice do you have?
What advice in terms of general advice of software for the software developers? Sorry?
आदि करके ले आओ
Um,
आई गेस खा लेंगे तो थोड़ी देर बाद खाएंगे ना खा लेंगे ना अभी अचानक से कैसे खाएंगे
I don't know why I cannot mute her. Acha. Sorry, sir.
Yeah,
Sorry for the
so,
disruption.
so a
Please
general
keep your
advice.
mics muted.
Sorry?
Yes, sir.
Mhm.
Yes, you can continue.
Yeah, so the general advice I will give to all new entrants, it's very I always talk that it's a what we call a 1996 moment. So in 1996, when we were studying, it was internet that was coming up, and internet was coming up in the sense that uh, it was in infancy, but so many people were so much excited about internet in all aspects. Like people had very fascinating ideas, fantasies about sci-fi's about internet, that this will happen, this will happen, this will happen. And to be honest, a lot has happened. A lot has happened, and those fantasies were true that we had. But now with this AI and machine learning, it's the same thing again. It's like 25 years later, we have now the same situation where people have a lot of excitement about something that is coming and something that is changing. And right now we are seeing that how it is changing. So, and everybody has different types of ideas in terms of what will happen. As a software engineer, what you need, there is a lot of discussion here that how AI and generative AI is going to impact the software engineering. Nobody actually has a fair idea what will happen. But I can tell you that software engineers can use this as a biggest, and obviously not people of my age can use that, but young people can use that as the most, like they can turn this risk into opportunity. They can actually make, I keep telling this to my young kids, my own boys as well, that this will produce a lot more new millionaires. It will produce a lot more new technologies, and you are there to basically make use of that opportunity. So just be happy and be excited about it, and I'm sure that you'll find a lot of opportunities in here. But always stick to the basics. If you are not sticking to the basics, then there will be problem, because basics are not going to go away anywhere.
Thank you so much, sir. Sir, we have a question in the chat as well. Ms. Fiza is asking, how do you choose between patterns when multiple patterns could solve the same problem?
Easy, simple. Simplicity is the key to the design. If you cannot make your make your design and your actual solution simpler, then it's a problem. So there is no second question in terms of, like, obviously fit to the purpose is another aspect. So we use two terms. One, fit to the purpose. So whenever you are deciding between two things, you need to make sure that the thing that you are deciding, choosing, is actually fit for the purpose, whatever purpose you want to use it for. But then once you have the fit to the purpose, then you need to choose a simpler solution, never a complex solution. Complexity is the killing thing for any software. And a lot of the software that died are because they were too complex. And I can tell you with my own experience in IBM, because I worked in that, the WebSphere application server. WebSphere application server was one of the one of the or like the main. They sold it for such a long time, 20-25 years, and it was the standard, industry standards. All the banks, everybody will use that, but it died. It died in front of many other applications, even Tomcat application servers, because of the complexity. So whenever you're choosing between an architecture or a design pattern, choose the simpler one.
Thank you so much, sir. Sir, मेरा भी एक सवाल है बीच में.
Sure.
Sir, how can we find, as students, I asked this, कि how can we find problems to learn more about design patterns? मतलब we know that design patterns solve a problem, but ऐसी क्या problems हो सकती हैं, a collection of problems available online somewhere, जिन पे वो design pattern apply
Well,
हो
as
सकते
I said, design patterns are used everywhere. So the best thing about best way about design pattern is to learn about design pattern is to recognize the design patterns being used. And as I said in the beginning, whenever you read these terminologies like adopter, like facade, like factory, strategy, you just open a code. Let's say you open, for example, an open source code for Angular or for MVC, some MVC framework, and you go through them and you're studying some classes or reading through that code, and you spot these terms in those class names. You will know that they are applying those terms. Even in IAC, for example, if you are studying Chef or Ruby-based code, or you are reading Terraform-based code and all that, wherever you are reading, and if you spot these terms, you will find that this is a design pattern. As a matter of fact, you can actually come up with your own design pattern names as well, based on understanding of your code or your own writing of the code. A lot of the time when we share our concepts in architecture, we don't share our ideas in terms of actual like those slides. We actually share them in terms of actual terms, and those terms we call them design patterns, design things. So it's not necessarily all these 17 design patterns that we are using, learning, and you will be doing. You can come up with your own design patterns and give them a name, make them understand to other people, and then use them in your day-to-day terminology. As a matter of fact, in all of the companies, what we use is as an architecture team, enterprise architecture team in, let's say, HSBC or in IBM, we will have a what is that called at the end of appendix that you have at the end of the book? Bibliography, not bibliography. What is that called? Where you list all the terms, and you then list in front of the terms, you list the actual, all that jargon that is being used in your company. You list what is the meaning of that jargon. So we used to have a section in that these are the design patterns that we use as a term. Whenever we are talking about this thing or using this term, it actually means this thing, and you need to go on this page or on this wiki page to see what it means. So you always come up with your own design patterns, and if you want to learn more, just read about them in existing literature. I can tell you, if you go on Google Scholar, you'll find thousands. Yesterday, when I was looking at that, I was amazed, because I have not been in academia for such a long time. So I was amazed that people still are writing a lot on that.
Thank you so much, sir. We can take one last question.
Sure.
Before we conclude things. How have design patterns evolved with the rise of cloud computing and microservices architectures?
Evolved. The question is how they have evolved.
Yes, sir.
Yeah. So okay, that's a very good thing that you mentioned. So the evolution has happened on the technology aspects. Evolution has happened on the actual implementations. So, for example, our technology in terms of the databases, in terms of the application development has improved. We went from first from in-prem to cloud, then cloud native, and so on and so on. So that evolutionary process is going on constantly. The design patterns, on the other hand, are not evolutionary. They are kind of bricks. They are like you keep on putting new bricks, new types of new bricks on that, and they actually become part of that evolution of those technology. So a lot of the time, if you would look at the design patterns, you will be coming up with a new design pattern, but that design pattern will not be actually an evolution of strategy pattern, for example. The strategy pattern that has been identified for a given scenario is the strategy pattern. It's not going to change. It's like the wheel. It's like the brick that will always be the same in configuration, same in size, same in whatever purpose it has to solve. So you may come up with the new things, not necessarily a new wheel, or not actually a new wheel, but a completely different thing that has no no relationship with the wheel, but it will be a new thing. So you can come up with the new design patterns, and people are coming up. Although I will tell you one thing which I noticed was that a lot of the time when we are talking, and I was talking in the cloud sphere, we write a lot of ISC, infrastructure as a code. And in the infrastructure as a code, when we are using these design patterns, which are primarily facade, facade is used a lot because facade and proxy patterns, they're used a lot. I find that we will be using them in exactly the way they were supposed to, they were there. And we won't be building new patterns at all because they are particularly good for whatever we want to solve. So what it means is that you may not look at the design patterns from the evolutionary purpose, but look at the design patterns from the purpose that they are there and you need more of them, and you need to use them in your thinking process. You don't want to be away from them. So that's the whole point. Make sense?
Yes, thank you so much, sir. Sir, लेकिन वक्त की कैद की वजह से I'll have to stop you over here. We'll have
No,
to
thank you very
conclude.
much. Actually,
So,
I was not, so I'm sorry about that, but surely if we will have another call, we will discuss more.
so any last words that you would like to say before I formally end this?
No, thank you very much. I appreciate your listening to me and feel free to stay in touch with me.
All right, I would like to extend our heartfelt gratitude to Sir Ali for taking the time to share his valuable knowledge and experience. Thank you so much, sir. आपने हमें समझाया और आपने हमें सिखाया. It was truly a valuable experience for all of us. Everyone in the chat, I have shared the feedback form. Kindly fill it because आपके feedback के बाद ही we curate more events related to your interests. So that would be very valuable. I've shared the link again.
All right. Thank you very much. The office.
Thank you so
Allah
much, sir, once
Hafiz.
again. Allah
No.
Hafiz.